Get started putting it all together. How do these concepts that you've heard about fit into fertility programs? We heard today from Bruce that we need to be a master of the basics. So if you want to make farming easy, all you have to do is master the basics. And these are the basics. Well, maybe farming won't be easier, but it'll be easier. You still have to contend with weather and markets. But these are the basics. Manage air and water in the soil. We got to create a home for the microbes in a favorable root growing environment. Manage crop residues. That's how we cycle nutrients and build humus in the soil. And then manage crop fertility. And it was stated this morning, one of the functions of crop fertility is to feed the plant, so it puts out root exudates to feed the microbes. So all these three systems have to work together. Regenerative farming is kind of a buzzword today, and there's a lot of people talking about regenerative farming. There's a lot of ideas of what regenerative farming means, but amongst the group that uses that term a lot, they have the 5 principles of regenerative farming. And really it's pretty similar to these 3 pillars that I just talked about. The one area that we would disagree on quite a bit, try to limit soil disturbance. There's many in that regenerative farming group that thinks all tillage is bad. Only no-till is acceptable. If you've been no-tilling for 10 years and you till one time, you just lost everything you've accomplished in 10 years of no-till. We definitely do not fall into that camp. Again, residue management is one of the pillars, and we feel like if you really want to build soil, build organic matter, and particularly humus, we need to recycle those crop residues quickly. And often that's hard to do in a straight no-till situation. So if we do enough tillage to at least get the residues incorporated and get that process going. No-till can work. We're not telling you not to do it. But if you're no-tilling, you still need to break down residue timely, and you need to have tilth. If you're in a no-till situation where the ground's like this and there's 3 years of crop residue, that system's not working very well. So sometimes just a little bit of tillage can jumpstart that and get the biology going, and then go back to no-till. And I've worked with one grower in western Iowa that comes to mind. He's been straight no-till for 30 plus years. And if you go out in his cornfield or bean field in August, all last year's residue is gone. He's got enough earthworm activity that the soil just has earthworm castings and hardly any residue. So obviously he's managing residue in a straight no-till situation. And he's growing a bushel of corn with about 0.6 to 0.7 pounds of nitrogen. So he's being very efficient too. So tilth matters. Dean talked about that extensively. If we're going to try to grow crops with reduced inputs, tilth is very important. Tilth affects a lot of things. It changes the way water moves in the soil. If we have good tilth, we're going to infiltrate more rain when it does rain, so there's less runoff, less erosion, less nutrients leaving the farm. Conversely, as soils dry out in the summertime, if we have good tilth, that water moves from the subsoil up to the topsoil by capillary action. So it works, it helps us out in both wet and dry weather. Changes the function of soil microbes. Most of our beneficial microbes are aerobic. They need oxygen to survive. And most of the pathogens tend to be anaerobic, so they live in an environment without oxygen. So if we have tilth, it creates a good environment for the microorganisms that we want to be present in our soil. And then it really helps with nutrient use efficiency, largely because of the impact on the microbes. If we have a good environment for them to work in, we're going to be more efficient with the nutrients that we apply. Obviously, ease of tillage, it's easier to till a tilthy soil than it is a compacted soil. Then weed control, it does have an impact on that too. We'll talk more about that later. So how do we get tilth? There's two factors. One is flocculation. That's a chemical process. That's why we pay special attention to calcium in the soil. We need soluble calcium to flocculate those clays, but then we also need the biology to glue those flocculated particles together into water-stable soil aggregates. So there's going to be microbes present in any environment, in soil or water or air even. What influences what organisms grow there? The resources that are there, food, nutrients, environmental conditions, such as pore space, but also pH, temperature, oxygen, moisture. So, Dr. Muir talked about many different groups of functional carbons. There's also many functional groups of microbes, and we'd like to have all these groups represented in our soil. I won't go over all of these, but we've got some plant growth promotion, disease suppression, plant nutrient availability, nitrogen fixation, carbon cycling, weed and pest suppression. So a lot of functions that microbes are either responsible for or play a role in. So we want all those communities present in our soil. How do we do that? And the rhizosphere is where it's particularly important. The rhizosphere is that soil immediately surrounding the plant root. And that's where the microbes are in the greatest abundance, feeding off of those root exudates. So the plant is a real trigger mechanism to encourage those organisms. So MVP is the product we work with now. Before that it was SP1, but MVP is a very broad spectrum biological product that brings a lot of those communities' microbial functions together in one product. It is a liquid. It's a very versatile product. It's compatible with fertilizers, pesticides, you name it. It's good for soil applications and foliar applications. So MVP, it supercharges the rhizosphere is the term I like to use. Dr. Muir talked about getting that cycle started, lighting the fire kind of. And the MVP is another product that does that. And if we combine those two together, we've really got a good situation. So MVP is a small thing that can make a big change in the soil. How does that happen? Well, it stimulates plants to grow more roots. And as they grow more roots, it puts out more plant root exudates. The exudates feed the microbes, and then the MVP makes sure that we have a supply of beneficial microbes there to multiply. And so that plant actually acts as a microbe incubator, multiplying those beneficial organisms. So that's how you kind of start that plant cycling, like Dr. Muir talked about. And then it kind of takes off on its own. About 2.5 years ago, we had DNA testing done on the MVP, and they identified over 140 different strains of organisms, bacteria, fungi, and so on. And to summarize it, 90% of them were involved in the nitrogen cycle somehow, and almost 55% were involved in carbon cycling. MT17 is another product, biological. It's kind of a sister product to the MVP, but it's designed to work in conjunction with manure applications. It's supposed to increase soil fertility and nutrient cycling by accelerating decomposition and sequestering carbon and building soil organic matter. So for that program to be effective, three things have to come together. We need the biological or the live microbes, which the MT17 supplies. We need active calcium in the soil, again, so it's flocculated. We have that pore space. We have an environment for those microbes to work in. Then we need abundant carbon to feed those microbes. And that's coming from the manure. That's a great source of carbon to multiply those microbes. So if we have those three things coming together, plus good soil moisture and temperature, we can make dramatic changes in the soil in a very short period of time. Another biological product that we work with is the Myco Seed Treat. That's a dry seed treatment, planter box treatment, or it can be pre-treated also. And that is a package of beneficial microbes, including mycorrhizal fungi. And the way the product works, you put it on the seed. When the roots emerge from the seed, they get inoculated with these beneficial microbes. The microbes then stay active in that soil rhizosphere throughout the growing season, helping to cycle nutrients and enhance plant growth. Another opportunity for working with increasing microbial populations is by inoculating residue. And the purpose to do that is to accelerate that plant residue breakdown. Again, we believe that's one of the ways that you really build soil, organic matter, and humus in the soil. And that can be done with your cash crop residue, but also cover crop residue. So the Residus WS is the biological product that the micro package that we use to inoculate the residue and accelerate decomposition. And then we put a food source with it. One of them that we like is our Prim Cal. It's a blend of calcium and the premium 21 humic acid that we heard about this morning. Another option is the Resicycle. That's a dry product that can be spread with dry fertilizer or solubilized and sprayed on. So ideally, we'd like to get that residue inoculated as soon as possible. Use whatever tillage is appropriate depending on your soil conditions. You know, it will work in straight no-till, but those organisms do live in the soil, so they need to be incorporated by tillage or rain for the most part. You know, if it rained every day, there'd be enough moisture on the surface to keep them going without tillage, but we can't count on that. So in a minimum till or no-till situation, a tool like the airway that knocks the residue down, gets it in contact with the soil, it's going to speed that process up. This is a field from northwest Indiana several years ago where a guy put the residues on with the airway on corn stalks the preceding fall. He no-tilled beans into that, but then he did cultivate to control weeds. You can see a line here. Here was 4 rows of point rows that he didn't want to have to make a trip down and back just to pick up, so he left the 4 rows without being sprayed with the residues. And you can see the difference. Here we've got corn stalks. Over here you don't hardly see any. 2 other things you notice in the picture. The soil is darker here. And also there's more clods here. Here it's nice and crumbly. If you speed up residue decomposition, you will improve soil tilth. It just automatically happens. It takes an army of microbes to decompose residue, and one of the byproducts is the polysaccharides they secrete, gluing those individual soil particles together into that crumb structure, or water-stable aggregates that Dean talked about. With that, I'm going to turn it to Monty.